Hi there. Thanks for stopping by. I didn't hear you. Hopefully by now you're comfortable with some of the compound interest material we've been looking at. You know, a big part of personal finance does involve vehicles and purchasing your dream vehicle the same way I have. So, let's going to give you a situation. Suppose Ben has $5,000 he's saved towards a vehicle he'd like to buy, and he's decided he's going to put that money away and let it collect interest for a year and buy his new vehicle in a year. Maybe that money collects interest at 2.5% compounded monthly. And that's somewhat of a realistic example, but we might wonder, how did Ben magically come up with $5,000? It's not very often you just all of a sudden have a lump sum of money. Maybe you inherited that money, that's a possibility. Maybe it came from a tax return, and we'll talk about taxes as well in this unit. That's a possibility. But more likely, Ben saved that money over time. Maybe he saved $50 or $100 every week or every month or whatever it might be. The idea of making savings over regular intervals like that, like $50 every paycheck or something, that's called an annuity. And that's the next part of the course we're going to look at. And we're going to learn that whether you're saving for a vehicle or whether you're borrowing money for a vehicle, in either case, that's what's called an annuity. And we're going to look at some of the math behind that. So come on, let's get to it. Oh, geez! Hey! Back here! So let's start with a simple problem about Ben and the $5,000 in his savings account that's going to collect interest at 2.5% compounded monthly. And we want to know exactly how much money Ben will have in 1 year for his new vehicle. So this is just like last week, just an example of using the compound interest formula, where our principal is $5,000. Our interest rate is 2.5%, but we have to divide that by 12 to get a monthly interest rate. It's compounded monthly. And in 1 year, that's exactly 12 months. So our end value is equal to 12. If you plug that in onto a calculator, you should get $5,126.44. So at the end of the year, Ben's $5,000 has turned into $5,126.44 because he's collected some interest, $126.44. Okay, let's move on to the new situation. In this situation, Ben still wants to purchase a new vehicle, and he still has a year to save for the new vehicle. But instead of having $5,000, at the end of every month, he's going to deposit $450 into a savings account that pays interest, again, at 2.5% compounded monthly. And the question is, how much will he have in his account after 12 months? Notice how different this is than the compound interest example. This is a series of payments, $450 every month. And that's an example of an annuity. So in this course, when we say the word annuity, we just mean a series of payments made at regular intervals. So that could be, like this example, Ben putting $450 into a savings account 12 different times over a period of 12 months. It might also apply to a loan as well. A loan is an example of an annuity. When you buy a car and borrow the money and you pay back the loan every month or every week, that's another example of an annuity. If you were to Google the word annuity, you probably hear a lot about insurance. That's not the definition we're using in this course. We're more broad with that definition. Any series of payments, we're going to call an annuity. Don't worry too much about this information here. A simple annuity is when the compounding period and payment period are equal. Don't worry too much about that yet. We'll talk a little bit about that later on. So let's revisit this problem with Ben. How do we figure out how much Ben will have after 12 months? I mean, one way to do it is $450 times 12, but that doesn't take into account the interest. And the interest is kind of complicated. Every month there's a different amount of money in his savings account, so a different amount of interest is collected. So one rather painful way to look at this problem would be to look at every single month on its own. So for the timeline of this, you need to realize that he's making these payments at the end of every month, and we want to know how much he has after 12 months. So technically the easiest one to figure out is the $450 he puts in at the end. That doesn't collect any interest because it doesn't have any time to collect interest. The $450 he puts in at the first month, that actually has 11 months to collect interest. And so that money, using the compound interest formula, okay, we'll just write here, will be worth 450. Take your interest rate, divide it by 12, and like I said, 11 months to collect interest. That actually works out to $460.42. So that first $450 collects a little over $10 in interest. The next month, that interest only has, or that money only has 10 months to collect interest because it's in there for 10 months. The third month, that money only has 9 months to collect interest. And let's see what happens if we continue the pattern all the way down. And there you see I filled in the rest of it for you from 11 all the way down to the month 11 only has 1 month to collect interest, and then month 12 no months. Now notice that these amounts are going to go down every time, 460 to 459, because every time I go down a month, that's 1 month's less interest that $450 can collect. So the money that's in there for the longest collects the most interest. Now I don't imagine you care to write all that out, and I don't imagine you care to add it all up, but if you do, you will find you get $5,462.31 total. Now thankfully, this is not how we need to solve problems like this, because could you imagine if we changed the question so that Ben was saving for, instead of 1 year, like 3 years? All those calculations, we'd have to do 36 of them. There'd be 36 payments. There is a formula to solve this problem for us, and there it is. It's called the future value formula, or final value formula for an annuity. It's not a simple formula, but it is pretty helpful. Let's just walk through it together. FV is the future value of the annuity. So in this case, it's the answer, 5,462.31, the final value or the future value. R stands for regular payment. So Ben made regular payments of $450. I is the interest rate. Now it's the same as the compound interest formula. The interest rate is per compounding period. So you have to divide it by 12 if it's monthly, or divide by 2 if it's semi-annually, or divide by 365 if it's compounded daily. And N is the number of payments, kind of like time. So as an example, we could use this to figure out Ben's final value of his annuity. And let's do that. So the R value is 450. So I'm replacing R with 450. Okay. Bracket, bracket. The interest rate is 0.025, 2.5%, but I have to divide it by 12 because it's compounded monthly. Okay, my N value is the number of payments, which is the same in this example as the number of months, which is 12. And then finally, my interest rate goes down here as well. Now, what I always like to do is I like to put brackets on your brackets in, because on your calculator, you're probably going to need those brackets down here, because your calculator doesn't know when you hit the divided by button, you mean there's a big fraction here, and so it's important that you have that. Now, you can get your calculator out now if you like and try to type all that in. It is sometimes a bit challenging to figure out how to get that all onto your calculator. There's a couple ways you can do it. You can type it in basically exactly as seen, as long as you include these brackets. If you have a calculator that shows what you're typing in, it's a lot easier. I'll show you a calculator I have on my computer here. And let's just clear that up. And we will try to work through this together. I'm just going to start with the numerator. So 450 times bracket, bracket. Okay, so I've got those two brackets there. Square brackets and curved brackets or parentheses doesn't make a difference. They both mean the same thing. 1 plus 0.025 divided by 12, close the bracket. My power button is right here on this calculator. It's kind of a funny looking one. Y to the power of n to the power of 12. Take away 1, close bracket. That's the numerator of the formula, the top of the fraction. I might as well hit equals right now. Okay, I get 1137. Divided by, and here's a very important set of brackets, 0.025 divided by 12, close the brackets, hit equals, and we see we get the exact same answer as before, $5,462, and if you round to the nearest cent, that is 31 cents. So it might take a bit of practice for you to figure out how to do that in your calculator. That's part of today's lesson for sure. Here's a simpler example. In order to save for her own college education, Rachel's grandparents provided her with a gift of $1,000 on her birthday. Rachel invests that money at 2.1% compounded annually. How much will she have after 18 years? So instead of saying on her birthday, I should have said every birthday. That's what I meant here. Every birthday. So 18 times every year on her birthday, she gets $1,000 put into the savings account to help for her college education. So again, it's important to understand that this is an annuity because we're talking about 18 different payments, regular payments, not a one-time payment. So we're going to use the future value formula again. Can you see why this example is actually a little easier than the example involving the car? Why is that? Well, the answer is that it's compounded annually. So we don't need to change the interest rate. We just need $1,000 for our regular payments. Our interest rate is 2.1% to the power of 18 years minus 1 all over 0.021. So this is a bit of a simpler example. If you type all that into your calculator, you should find that you get $21,602.94. That should seem reasonable because if they gave her $1,000 every year for 18 years, that's $18,000. But instead of having $18,000, she has $21,000. Why? Because she made over $3,000 in interest. Okay, for our next example, we've got Gary, who is 35 years old and saving for retirement. He's paid bi-weekly, and $100 from each paycheck is deposited into an RRSP. That's also compounded bi-weekly, paying interest at 3%. I mean, first of all, you need to know that bi-weekly is every other week. So Gary gets a paycheck every other week. There are about 52 weeks in a year. So he gets paid 26 times a year. Now, we'll come back to the RRSP part in just a minute. For now, all you need to know is the interest rate and the regular payments he's going to make. He's going to make these payments until he's 60. And we're going to figure out how much money he has to retire with. So $100 every other week for, in this case, 25 years. So the number of payments in this example will be 25 years times 26 paychecks in a year, which gives us 650 regular payments. Now the interest rate is 0.03, but it's compounded bi-weekly, so we'll divide by 26. Now there aren't exactly 52 weeks in a year, but we're not going to worry about that too much. This is still going to give us a pretty close to the right answer. So let's just look at calculating the future value here. The regular payments are $100. The interest rate, which we've shown to the side already, is 0.03 divided by 26 to the power of 650 minus 1 all over 0.03 over 26. If you plug all that into your calculator, I know it is tough and it does take some practice, you should get $96,727.36. Which is definitely not enough to retire off of. We'll talk a lot about that later on. The other question here is, how much interest has he earned? Well, if he made 650 payments of $100, then that is $65,000 that he put away. Yet he has $96,727.36. So the difference is the interest. So we get that just by subtracting. Which gives us interest of $31,727.36. So there's our interest that's earned right there. And this, of course, is our final or future value.